Hey everybody, we are going to be talking about multiplication and the strategies that we are using to solve multiplication problems and the theory behind multiplication. So, jumping right in, here are our big ideas. When thinking about multiplication, we're considering the number of equal groups. Okay? Really thinking about groups, but really equal groups, because that's the main principle of multiplication, is finding your number of equal groups and seeing how many objects are in each group, the number of objects in each group, those equal groups, and then to help us find our product, or the total number of objects in a scenario. We want to know how many total objects we are considering in whatever situation we're talking about. So the answer to a multiplication problem is the product. We need to work really hard at remembering that language, that word, because a lot of our questions are going to say, find the product of 2 and 4. Okay, so that cues me in to know that I need to multiply. The answer to an addition problem is called the sum. The answer to a subtraction problem is called the difference. We're finding the difference between two numbers. The answer to a multiplication problem is called the product. The answer to a division problem, which we're going to be talking about soon, is called the quotient. So, but multiplication today, that's what we're thinking about. Our language, we have a factor times a factor is equal to the product. Okay, the numbers that you multiply together are the factors, and our product is the answer. So keep those in mind as we're working through this. We're going to discuss some different strategies. It doesn't matter to teachers which strategy a student uses. Usually a student will have one strategy, maybe two that they like to use, and stick with it. No one has to be proficient. We want everyone to understand the strategies, but once you kind of find one that you like, as long as you can get the correct answer, we don't care as much. As long as you understand the ideas behind the strategies and that you know how to use them properly to develop that deeper understanding, that's important. But there are different ways to multiply. There are different ways to find the product, and usually people and students find one that works for you and they kind of stick with it, which is great. But I'm going to discuss different strategies that we like to use, and just so you can be exposed to them and see which one works the best. So we're going to talk about equal groups, building an array, skip counting by finding the multiples, and then repeated addition. So first of all, we're going to start with equal groups. So let's consider 3 times 4. Okay, 3 times 4, and we want to find the product. 3 and 4 are our factors. I'm going to put F for factors, and then our product is going to be here, just so we can see that representation. So when we're considering equal groups, just for teaching purposes, we're going to start with the 3. So that means we're going to have 3 groups. 1, 2, 3. 3 groups, and there are 4 objects in each group. So I'm going to do tallies, and we'll see. I'm going to do an example in a second that'll show why tallies. I like to use tallies. So we're going to do 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. A real-world example of this might be that a farmer has chickens and they're collecting eggs. So the farmer has 3 baskets, 1, 2, 3, and they put 4 eggs in each basket. How many total number of eggs does the farmer collect? So then we would know we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the farmer would have 12 eggs total. 3 times 4 is equal to 12. So this is a pretty simple, a basic way to using equal groups to find the product. This gets a little bit lengthy for when we're multiplying bigger factors, it takes a while and it can get sloppy, which can lead to errors, but it's a good starting point. Let's look at another one, which will show why I like to use the tallies. This time, we're going to do 4 times 6. Okay, same thing. 4 and 6 are our factors. We're going to find the product. So I'm going to do 4 circles for our 4 groups. And then I'm going to put 6 in each group. Now, when I'm building my 6, I'm going to do tallies of 5, like this. 1, 2, 3, 4, 5, 6. Okay? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I like to do this because when we're counting, you can skip count by 5s. 5, 10, 15, 20. And then I can just go back and count my ones. So I have 20, 21, 22, 23, 24. So my product is 24. And you can do this the other way as well. If you wanted to draw 6 circles and put 4 in each, we know that that works as well because of the commutative property, which I'm going to talk about a little bit later. But whatever way you understand, whatever way works the best, they can both do well. Okay, like for example, if you had 9 times 2, you don't want to. It's going to take a long time to draw 9 big circles. It would just be easier to draw 2 circles and then put 9 tallies in each one. That's what I would do. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's faster and more efficient for me. So that's our equal groups. We can do that for any factor, and we'll find the product. The downside is that it can be lengthy and take some time, and if we're not organized, we could get in trouble with miscounting or making an error. But a good strategy to start with to find the product. The next one is an array. So let's consider our multiplication sentence. Let's do 3 times 4 again. So in this one, when we're building an array, we're going to have rows and columns, or rows. So rows are, the number of rows are groups. So we have 3 rows, and there are going to be 4 in each row. So we're going to have essentially 3 groups of 4, but we're going to build it like this. So we're going to have 1, 2, 3, 4. There's 1 row of our 3. Then we're going to go to row 2, 1, 2, 3, 4. There's 2 groups of 4, and then 1, 2, 3, 4. Another way to represent, we see these a lot in 3rd grade math. We have 3 groups of 4 objects. It's another way to represent it. I like to use X's because I think they're kind of easier to line up. Some people like to use dots, but if we're not careful, again, it can get messy. So that's the array. Pretty straightforward. Let me do one more. Let's do 7 times 3. That means then you would have 7 groups of 3 objects, or 7 rows of 3 objects. So 1, 2, 3, 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7. And you could skip count by 3s if you wanted to. You could go 3, 6, 9, 12, 15, 18, 21. Skip counting by 3 down, which would be listing the multiples as well. Or you could count them one by one. Whatever you need to do to find the product. So we know that 7 times 3 is equal to 21. So that is our strategy to find the product by building an array. So we're looking at our groups and number of objects in each group. So this should be, you should have 7 rows, and there are 3 in each row. And your product, again, is the total number of objects. So a real world example for this one could be a teacher setting up chairs for a performance in their classroom. There are 7 rows and there are 3 chairs in each row. How many total chairs does the teacher need? We would see 21. So that's a way that might be used in the real world. The next one we're going to do is repeated addition. So let's pick our go-to 3 times 4 again. We're going to find the product. So repeated addition, we know we have 3 groups of 4 or 4 groups of 3 because of the commutative property. So if we have 3 groups of 4, I have 3 4s. Okay, so we're just adding those together. And that's essentially what multiplication is just repeated addition. Some students really like this, especially when we get to bigger factors, because you can add it together. I like to do this. I'm going to do, to find the product, 4 plus 4 is 8, and I just have one more 4. I'm going to bring that down. 8 plus 4 is equal to 12. So that is our product. 3 times 4 is equal to 12. Let's do another example with this one. Let's do 6 times 7. 6 times 7. We're going to find the product. So I have 6 groups of 7. So I'm going to add 7 together 6 times. 7 plus 7 plus 7. 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, we're going to find the product. So in examples like this, I'm going to do the doubles first. I'm going to group my 7s. Make sure you don't add them twice. So 7 plus 7 is 14. This one's 14. That's 14. And from here, you can go different ways. Sometimes I just like to come over here and stack them up. Or some like to continue adding those together. So you'd have 4 plus 4 is 8. 1 plus 1 is 2, 28. And then we still have this 14 to bring down, plus 14. Then you could stack up 28 plus 14. It's whatever you're most comfortable with. Then you would have 8 plus 4 is 12, and then 42. So our product would be 42. Okay? Or you could come over here and do it this way if you just wanted to eliminate that step and just add the 14s together. You could do 4 plus 4 plus 4 is 12. And then add 4 1s together, you have 42 to find your product. So that's repeated addition. If you did it the other way, if you wanted to add 6 7 times, which is totally okay, let me show you just what to be careful about, because this can get confusing. If you wanted to add add 7 6s, 1, 2, 3. Okay, we're good here. So I'm going to do the same thing. I'm going to do my doubles, but I have 1 extra down here. It's okay, so just watch what I'm going to do here. So I'm 6 plus 6 is 12, 12, 12, and then I still have 6, okay? I'm going to go ahead and add these together. So 12 plus 12, do our doubles, we have 24, and then I'm going to add 12 and 6 together, which is going to be 18, and then I'm going to come over here to the side, 24 plus 18, 4 plus 8 is 12, and I've got 42. Same thing. But I just wanted to show you when you have that extra, you just bring it down. Okay, so this is repeated addition. This works well, especially when we get to bigger factors. We just have to be solid on our mental math facts and our addition, comfortable with addition. So that's what we want to consider there when using a repeated addition. But repeated addition is the heart of multiplication, so it's a really great strategy to implement when working. Okay, skip counting to calculate the multiples. And that's kind of essentially what repeated addition kind of leads to this, but we're just going to break it down into different steps. So we're going to do 5, let's do 6 times 5, okay? So skip counting, we're just going to start, when we're skip counting, we're just picking one of these factors, and we're just going to add it to itself over and over again. So let's do 5s first. If we do 5, we're going to skip count by 5 6 times to get our product, okay? So we're going to do 5, that's 1, 10, 15, 20, 25, 30. So this would be 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, and 5 times 6, okay? So that's how we're getting our multiples. The multiples are just the answer to any number you multiply by a product, okay? So if we picked 5s, all of these are multiple of 5. So any number you do 5, you could do 5 times 99. That product is going to be a multiple of 5. You could do 5 times 1,000. That answer is going to be a multiple of 5. We could also do it the other way. If we listed them, if we skip counted by 6s, we're going to list the multiples of 6. We're going to start with 6, and then 6 plus 6. So this would be 6 times 1. And this one would be 6 times 2, so that would be 12. Then we do 6 times 3, 18. 6 times 4 is 24. And then 6 times 5 would be 30. So we would skip count by 6 5 times. We get 6, 12, 18, 24, 30, and we're going to get the same answer, okay? So that is the skip counting to calculate the multiples to find the product. That's a great strategy to use and very efficient and goes pretty quickly. The issue is if we make adding errors getting from one number to the next, okay? So we got to be very careful about that to not, make any mistakes here. We're just adding 5 here, and then here we are adding 6. It can go either way. Whatever is easiest and makes most sense, that's the one we want to use. So if you have your easy numbers like 5s or 10s, we want to skip count by those. Okay, I talked about the commutative property earlier. That's basically, we're going to go back to our handy dandy 3 times 4 equals 12. The commutative property says that it doesn't matter which order your factors go, you're still going to get the same product. So it doesn't matter if we have 3 times 4 equals 12. So if we have 3 groups and 4 in each group, or if we have 4 groups of 3. It doesn't matter. We're still going to have the same number of total objects. So this would be 3 times 4. This would be 4 times 3. And they're all equal to 12. They're all equal to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in any multiplication fact, I could have 99 times 100. It's going to be the same as 100 times 99. Okay? Same idea. It doesn't matter. If we have 7 times 6, we know that 6 times 7 equals 42. That's the commutative property of multiplication. So we just need to have an understanding of that. It doesn't matter which order our factors are going in. It doesn't matter. Okay? Commutative property. The associative property is a little bit different, but the same idea. If we have 2 times 3 times 4, hang on, let me change this. We have 2 times 3 times 4, and let's say we put some parentheses there. Parentheses are just a way of grouping the numbers. That just means you want to multiply those together first. But the cool thing is, if we have the same if we're multiplying the same numbers, the associative property tells us that it doesn't matter where the parentheses are. Okay, so if we do 2 times 3, we know that that's 6, and we still have the times 4, so we're going to bring that down. Times 4 is equal to 2 times 3 times 4. We know that that's what? 12. So 6 times 4, 4 times 6, count those 24 kicks. So 24 is equal to 12 times 2. To do anything times 2, we're going to skip count by 12. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay? So skip count by 2 12 times gets us to 24. And we see that 24 is equal to 24. So we have here that they're equal, they're balanced. These two problems equal the same thing. So the associative property says it doesn't matter where the parentheses, these things are parentheses, it doesn't matter where they go in a multiplication problem. You're still going to get the same product. Okay? If we have 4 times 3 times 5, and we have parentheses here, that's still going to be equal to 4 times 3 times 5. If the parentheses are there, it's going to be equal to the same thing. If I do my parentheses first, 3 times 5 is 15. 4 times 15 is going to be equal to 4 times 3 is 12 times 5. If I add 15 together 4 times, 5, 10, 15, 20, 2, 3, 4, 5, 6. So that's going to be 60. And over here we should have 60. So let's do our 12s trick. We're going to do 12 times 5. 5 times 11. Remember our first step is going to be 55. And then we're going to change this to a plus. 55 plus 5 is 60. So we're good. So that is the associative property. It did not matter the order or where the parentheses were located. We still got the same product. The last thing I'm going to discuss is multiplying by a multiple of 10. We see this a lot in 3rd grade math. Not difficult, but we have to have a deep understanding of why this works. So a multiple of 10 is any number that you multiply by 10. That's whatever the product is going to be. So anything you can skip count by 10s. 10, 20, 30, 40, 50, 60, on and on and on and on until infinity. Those are going to be multiples of 10 because 10 times 1 is 10, 10 times 2, 10 times 3. You get the picture. Okay? So let's say we're going to go back to our let's do this. We're going to do 30. This is the multiple of 10 times 4. Okay? We discussed about how multiplication is just repeated addition. One way I could solve this is just add 30 4 times. Okay? That's one strategy we could use. Add 30 4 times. And that's perfectly fine. But what I want us to also think about is how can I use 3 times 4 to help me solve this? Okay? So I know that anything that's a multiple of 10, I just multiplied it by 10. So 30 is 10 times bigger than 3. Okay? So let's think about this. If it's 10 times bigger, we have a 0 in the ones place, and we have 3 10s. Okay? Our 4's a 4 in both of them. So if I know what 3 times 4 is, so 3 times 4 we know is 12. 30 times 4 is just going to be whatever 3 times 4 is, just 10 times bigger. So it's going to be 120. Okay? Because if I did 12 times 10, if I did 12 times 10, I know that would just be 120. So whatever this is, the product here, is just going to be 10 times bigger. Or you're just going to move the place value. That's not how we should explain. I want you to understand that it's 10 times bigger. The product is 10 times bigger, but functionally what we're doing is just adding a 0 to the end, okay? But if I wanted to solve this using the repeated addition, I would see, okay, 0 over here, I'm looking here, zeros, and then 3, 6, 9, 12, same thing, okay? Let's look at another one. Let's look at another one. Let's say we wanted to do 3 times 60. We want to find the product. 3 times 60. So I could add 60 together 3 times because of repeated addition. That would totally work. I could also look at 3 times 6. Okay? 3 times 6. Let's list our multiples. We're going to list 6 since it's the bigger number. So we're going to list 6 3 times. So we're 6. 6 plus 6 is 12. 12 plus 6 is 18. So this is 6 times 1, 6 times 2. This is 6 times 3. So it's the 1, 2, 3. It's the third multiple we're listing, 6 times 3. So I know that 3 times 6 is 18. So I know that the product of, if this is 18, the product of 3 times 60 is just going to be 10 times bigger. So I'm going to have 180. Okay? So don't get bogged down by 60 is a huge number. It's a multiple of 10, and we can use our friendly factors, our friendly multiplication problems that we've been working on for a long time to help us to solve these. Let's do one more. Let's do 40 times 8, okay? 40 times 8. So I could list 48 times. I could. That's going to be a lot. So let's think about this. 40 times 8. So let's think about 4 times 8. We're going to use that to help us find the product of 4 times 8, and then we just know that the answer to 40 times 8 is 10 times bigger. So 4 times 8, we can let's do repeated addition for this one. We're going to do, let's add 8 4 times. 8 plus 8 plus 8 plus 8. Okay? 8 plus 8, 16. 8 plus 8, 16. 16 plus 16. If you need to stack it up, you can. 6 plus 6 is 12. 1 plus 1 plus 1, 32. So we know that 4 times 8 is 32. So 40 times 8 is just going to be 10 times bigger than 32. So it's going to be 320. Anytime a number is 10 times bigger, it's moving to the left. And you're going to put a 0 in the ones place. Okay? So use our friendly fact to help us find the product of our multiple of 10. We'll get lots of practice with these. Just wanted to give you all an introduction. If we're working on homework or practicing, this is a good strategy to have, and we'll be seeing lots of problems like this. And that's all I have for us. Let me know if you have any questions, and great work.